Hi, this is Tavi Greiner, Astronomy.fm's Vice President of Communications. If you enjoy our programming, please let us know with a donation to astronomy.fm/donate. We really do rely on your support, and it's true, every little bit counts.
AFM.
Program complete. Enter when ready.
The curtain of night is drawn back. The telescopes are trained. The domes are open. The audience is set. Now, step into the event horizon.
Good evening, everyone, and welcome to the Event Horizon here on Astronomy.fm radio. It is another Friday night. This one is March 15th, 2019, about 9 o'clock in the evening for those of us here in the eastern portion of North America. That is, of course, daylight savings time, by the way. So Universal Time would put it Saturday morning, March the 16th at, was it 1 o'clock in the morning, I think, Universal Time?
1 minute past 1 in the morning. Oh my God, it's early.
Well, it's earlier for a lot of other people, even earlier than that for others, too. The farther east you go. Yeah, super early.
But as I say, the further east you go, the more fun you get. We had a good launch this evening.
Yeah, what was it that launched? I tried to see it, but
it was a WGO-10 communication satellite for the U.S. military, for the Air Force, on a ULA Delta Alliance 4.
And it was a bit delayed by a couple hours, 2.5 hour delay for some reason. I was going to watch the beginning of it, and I didn't. Then I popped in a little later, and then
I saw you there, Marty. I saw you typing astronomy.fm.
Yeah, whenever there's a launch, and I catch it, whenever there's a live launch, and it's got a chat on it, sometimes they put it into, whether they put on NASA or NASA Facebook page, or this one happened to be on, YouTube, yep. And I was able to get into the chat, and I always pop in just at least once, astronomy.fm. That's all I do.
I saw you do it at least twice.
I think I did it once this time.
No, twice. Anyway,
I don't remember.
Saying that, it's me, Nick Yvette's 2 Echo Zero Lima Uniform November. And in our chat room tonight, apart from me and Marty, obviously there is Starstrom, Glenn, Black Projects, and Evil Spock. Live long and prosper.
Indeed.
So
glad to have you all here. Plenty of room for everybody else to get into chat room too. Go to the homepage, astronomy.fm. You'll see down near the bottom where to click on that link, and it'll get you to the chat login, which is just type your name and hit login. No password.
And
erase the passwords. Go ahead.
The video will be available probably from about midday or slightly later tomorrow on the AFM Facebook page.
Video of our show?
The video of our show, yes.
Oh, it's going to be like watching submarine races at nighttime.
Basically, it's going to be a couple of AFM logos, really.
Yeah. But the audio is us.
But the audio is us, yes. The links will also be in the chat along with the video, thanks to Starstrom as ever. So yes, that will all be there. And I have to really say, I still think SpaceX do it better than ULA Delta. Sorry. At least we get to see a human face and we hear them talking, particularly if the launch is on the SpaceX page. Yeah. We get told what's going on much better because the audio levels kept dipping in and out. So they didn't really want us to hear what was going on.
I know that it was a lot of audio. And I'm thinking, is this audio even working? Maybe yes, maybe no. Then I'd hear a blip of something once in a while.
Yeah, it was working, but it was like really, really quiet. And a lot of it was, I suspect, was being kept because somebody was being an idiot and didn't want the rest of the world to know.
They need to hire us, is what it is. They should hire us as the audio commentators of launch. But we'd have to speak for at least 2 or 4 hours, depending on how long they want to keep delaying launch. So. But we could figure it out. We could do it.
Oh yeah, we could do it probably a lot better than ULA Delta does it.
We could, yes. We could digress a lot too.
Well, yeah, digress. Yeah, look at what they do. They must be the best at digressing ever. A history of the Thor missile, history of American satellites. Yeah, right. The early Delta models, all as filler because somebody's done something wrong. And yes, Glenn, we shall teach. If you're in the chat room and you type in the chat room and make comments, we see them and we do react to them. See, I just reacted to what Glenn said. He says, "Do not talk." Well, you know what? We have a license to digress. But as I say, yes,
We could do it. Maybe they're listening to us. Maybe they saw the link I put in, and they're listening to us, and they're considering hiring us.
I hope they are, because let's face it, they've really got to be a little bit more forthcoming.
I think so too.
Going to holds and not really explaining the hold. It's not fair. A lot of people obviously spent a lot of time sitting in the chat room that they had there, going on the YouTube page, listening and trying to figure out what was going on. Are the comments inane? Yes. And are they puerile? And are they juvenile? Oh yeah, tons of them. Us, no. We simply mentioned was astronomy.fm. Okay, I chucked in a few Agent Coulson references, but I got fed up with all the Buzz Lightyear ones.
Oh.
No,
we can do it. You never know where you'll be hearing us the next launch, if there is one.
Who knows? It'll be quite busy. And of course, Mr. Muskie, if you're listening, we would love to come and work for you in your PR department, talking about your launches as they happen. We could do that for you.
But they do a pretty good job.
They do, actually. I will say they do an excellent job. I'm looking forward to seeing how Steve Bezos deals with his launch when they come to show. And I really hope they do live videos cutting to and from launch control. Yes, you are, Glenn. You are definitely boots on the ground as well.
So one thing we could definitely do is, if we don't have any real information, we can make up all kinds of stuff.
Oh, if we want to, we could fill at least 4 or 5 hours with waffle if we had to.
That's right, and all of it inaccurate if we had to.
Well, let's face it. A lot of the time, what you get is spin. It is waffle, because someone behind the scenes is probably running around like an idiot trying to figure out what the hell's going on, or what do we tell the public.
Yeah, well, we'd be extremely inaccurate, though.
Well, I'm hoping that if we're doing it for them, they would give us a lot of all the information we require.
Well, yeah. Sometimes they don't know themselves. They're testing systems, so they don't have any real information. It's something, something in a computer glitch. That'd be the standard answer.
Yeah, and seeing some of the comments, oh yeah, their Windows is updating, and it's taking a long time.
Oh yeah, everybody was hitting everything in the comments, just like try unplugging it and replugging it back in, blah blah blah. Some of it funny, some of it a little too cutesy, and some of it just stupid. The commentary that others were making.
Oh yeah,
their chat room, by the way. So, well, try getting into it. Next time there's a launch of something, try getting into the chat rooms and check it out sometime and see what things are going. And of course, encourage you, just type in astronomy.fm and we'll see how much more we get our name out there by being in live chats for launches. How about that?
Glenn says, oh, my accuracy is not a relative term. I think in a lot of cases, when you're doing a live launch, the suspense keeps people watching.
Being delayed for a couple hours is really not too bad. I know people that have gone down for launches like Saturn V's and stuff like that when the delay was a week. You take some vacation time, take a long weekend vacation time to go see a launch, and it's delayed by a week, and you don't get to see it. You already come home, and then they launch it. I think somebody once told me they saw the launch on the airplane flying back home.
That would not surprise me.
It was delayed by that amount. So that sucks.
It's happened with the shuttle as well. And it's just one of those things. This is the problem is with Space Coast tourism. You go there for a launch. You really need to say, right, I'm going to arrive a day before the launch, and I'm going to stay until a week after the launch.
And it might not be enough time.
Still might not be enough time, but it gives them enough time to get everything sorted, and maybe you get to see your launch.
Yes. Well, you never know. I mean, could be down to the bathroom break missing the launch too.
Oh yeah. No, I'm not going to go there.
Nope.
I
I'll
was going to say, well, there are several astronautic ideas on how to not miss something.
I left it at that. Yep. All right. Let's see. We've got some more launching stuff coming up. Let's see. We've got next Friday. A couple astronauts are going to do a spacewalk, and then the Friday after that be another spacewalk by two astronauts. I think that's the last. Let's see, not any other launches scheduled recently for. That's a new crew that's on the space station right now. So at least nothing through the NASA news about any launches to the space station or from the space station or anything like that. So. Oh, let's see. I checked the sun. Nothing happening on the sun. All quiet.
Nothing new there.
In the sunny front there. Yep. Bennu.
Yeah.
Nice close-up picture of asteroid Bennu. That's in the NASA webpage. Let me put that into our chat room there. Like rocks, and smaller rocks and bigger rocks and whale-sized rocks and stuff like that. So let me put that link into our chat room. Starting to see a lot of extremely gravelly types of asteroids. Bennu and Ryugu.
Yeah.
Are extreme rubble piles, at least on the surface.
Now that's an interesting thing because this is something that's been surmised for quite a while. And they were unsure whether what we were going to find was a conglomeration of rubble, or was it going to be a case of a solid piece of rock. So what we're actually doing, these two missions are giving us some very, very good cutting edge science, because that way we get a better idea, and then we can look at older images that have been taken with other telescopes, and say, well, okay, this is similar to Bennu, to Ryugu, and we can say, well, okay, so this is more like a Ryugu class job. This one's more Bennu class. This one may be more like Vesta or Ceres. So yeah, the whole point is we're getting somewhere.
I think kind of a little bit of both was Churyumov Gerasimenko 67P.
Yeah.
Two obviously lumps attached together and a little bit, well, a moderate amount of little debris all over the surface, but mostly bigger rocks on the surface. A lot of spaces in between, if I remember seeing those images. So I think size is so far kind of determining the composition of what asteroids are made out of. Smaller stuff has been more debris, and larger stuff it gets squished together and it's less smaller debris.
Well, as I say, the thing is it's long been thought that not everything is going to be one of these nickel iron jobs,
right,
that the science fiction writers are so beloved of. It's not something that's going to be big and solid that you can land a space capsule on and put a flag on and say, I take this in at your own name.
Yes, right. Now this kind of puts in perspective things like what was the big rush? Tunguska,
yeah.
Yeah, now that was one of these types of asteroids where it was just really a debris pile. That would explain more of the airburst and disintegration.
Well, yeah, but was Tunguska a comet or was it an asteroid?
And a gravelly asteroid like these two are.
So that's the big problem. We really don't have any really good records. And because of that, we can't say for certain it was either the nucleus of a comet that became an airburster, or is it a pile of gravel that came into the atmosphere together. Yeah, it was a 15 to 30 megaton airburst. Thank you, Black Projects. But the thing is, Yeah, very, very droll, Glenn. Glenn is saying, was it a failed missile from the US? That time, I don't think so.
1909, I think it was, something like that.
That would be a cannon shell, if
There
anything.
you go.
Nice one, Glenn. Anyway.
Now, the Behringer meteor crater, that obviously had a lot of iron in it.
Yeah.
Because they were finding that all over the area. But they did not find it deep in the middle of the crater, though.
It became shrapnel.
Yes.
And I actually have a piece of Nicoline meteoric shrapnel from Cannon Diablo in Arizona.
I do too.
Dated at 20 to 40,000 years ago.
Mm-hmm. I have a piece too.
I know, Glenn. That's the nice thing. You people see. This is what we always try to get over to you all at the beginning of the show. In order to have the maximum fun. And hi, Redshirt3, glad to see you here. Is join the chat room. You don't have to use a password. Just type a name in. Ignore the password bit. Come on in. Talk to us. Share links. Ask questions. Quite possibly, Glenn. Given the fact that the remote area and the local population were very scattered, it's a very scarcely populated area, mostly reindeer herders, I believe. So who knows what's going on? At best, yeah.
It's almost nobody. I think it was a wooded, very, very wooded. It was obviously, it was a very, very wooded area, like pine trees.
Yeah.
No, it's pine trees. Lots of pine trees because they're all blown down except for the ones right in the middle, which are just,
vaporized.
The burst hit straight down. They were pointing straight up. Their branches stripped down off of them, though. So,
but as I say, that's the big problem. We don't know exactly what it is. The other one, of course, was the Chelyabinsk airburster. We have a bit more knowledge about this one because we can backtrack it.
Particles have been found.
From
that one. I have a piece of that, by the way.
Yeah, nice. Now, the meteor crater was the last impact energy has been estimated at about 10 megatons, according to Black Projects.
Okay.
So when you think about it, we really have no really good idea what caused the Chicxulub crater, which which began the extinction of the dinosaurs. That is one we really don't know what it is yet.
Because that was really big.
That was very, very big.
Yep.
And of course, we're now discovering with the radars on the satellites, the ground penetrating radars we have in space pointed at the ground, we're discovering more and more craters. There's been at least 2 found in Greenland. Yep. There's been a major one found, I believe, in Ontario, Canada.
Recently,
as a result of an impact.
Well, there was where the Ontario, Canada was the one in Sudbury.
Yeah,
that's what I'm thinking. Or was there a different one instead of Sudbury?
Well, the one they found in Canada was also mostly submerged.
Okay.
So they were using sonar as well. Now, the nice thing about using radar from space is that it can see. It's kind of like flying an aircraft over a cornfield in a very hot summer. Because when you do that, I'm putting my archaeologist hat on, by the way. What you can see is the outlines of old walls, of old habitations, which come up because of the drought. They're more visible and they show through the crops. Now, a lot of these have been put. Somehow, is this a crop circle from another planet? No.
Well, crop circles are a lot of crop.
Yes, they are. Alien created crop circles are the biggest load of Feldergarb going. Yes,
it's the big load of crop.
Because there's somebody there with a big flat board, ruining a farmer's living, and winding a lot of people up.
You don't get those much anymore.
No, they seem to have died a death.
And
yeah, there's Richard says also a big crater buried at the mouth of the Chesapeake Bay in Virginia.
Yeah, okay.
So again,
I can't remember how many there are around the world. 100 maybe tops.
There's one in Australia, I believe, as well. That's been confirmed as being a meteor hit. So yeah, as I say, we have eyes in the sky looking down on the Earth, and we're now beginning to find these massive impact features.
Mhm.
So it's not just one or two we're finding; it's several. It's more and more as time goes on. As the look down, as the radars as they improve, we're seeing more and more of these locations. So, of course, in a lot of cases, like the Chesapeake Bay one and Chicxulub, it is going to be very, very difficult to find anything from anything that survived the impact.
Right.
Now, with Chicxulub, we have a very nice telltale in the KT boundary. It's called iridium. Iridium is actually a very, very rare metal on Earth. But there is an overabundance at the boundary between the Cretaceous and Tertiary periods.
And all over the world, too.
And all over the world, too, yeah. So it's not just one area that's happened. This has happened. This is through the whole layer all around the world. So that does point to a large visitor from outer space. And, of course, about, 20, 30 million years ago, we had the late Great Bombardment going on. And, of course, that gives us a lot of our current lunar features. Yes, Glenn, our crust is constantly being rebuilt. So finding old craters is very, very hard. And according to the Black Projects has put in a comment that the Chicxulub impactor has been estimated at 21 to 921 billion Hiroshima bombs. And just think how it changed the world's weather. With the amount of stuff that was put into the atmosphere, it created what became known as a nuclear winter. There was flash fires all over the planet, so all the soot was going into the air. There was all of these, everything else was being pushed up from the impact. So literally the temperatures dropped around the planet very, very fast. And first the herbivores started to vanish, started to die off because there's nothing for them to eat. And after a while, the carnivores followed suit. Obviously, for mammals, it was probably the best thing since sliced bread because it gave them dominance.
They were mostly below ground dwellers that probably survived, they were thinking.
Yeah, because mostly they lived underground. They were timid because of the carnivores that were in existence. A timid mammal with a small body mass is probably a breakfast or between meal snack for maybe a velociraptor or maybe a rex.
Still a fair amount of roots to eat.
Oh yes, there'll be plenty of fibrous material that they can digest much easier than the large herbivores and some of the carnivores. And of course, a lot of people say, well, where did dinosaurs go? The dinosaurs eventually, if you look at how their bone structure is, became the birds we know today.
Yep.
Because they evolved. The ones that survived evolved and became birds. Good evening, Optronics. Welcome to the show. And Redshirt 3 is saying the only reason the Bay Crater was found is because they're investigating why the underground water quality was so bad. And why did the dinosaurs say see ya? Because they didn't have a space program. End of the day, this is why a space program is so important to us humans on the planet Terra. Because at the end of the day, hopefully, if we get enough warning, we can probably save a small portion of the population, save a cross-section of biosphere, and either move on to space stations or go to Mars and start over there, or the moon. So there is possibilities. That's the important thing. Also, a space program allows us to be in a position to try and do some form of deflection on the objects. So that's why we have near-Earth object programs. That's why we have Space Watch and NeoShield, because these programs, a lot of them have amateur astronomers who track the objects. They are found and reported to the Minor Planets Center. And as Brian Marsden say, if it moves or goes bang, I want to know about it. And that way, they put out the actual data on the orbits. The amateur astronomers, people like Guy Wells and Daniel Bamberger at the Northrop Observatory, track these objects, they image these objects, and it all helps refine the orbit. And of course, Apophis is a famous example. A lot of the orbits said, "Oh, it's going to crash into the Earth in about 2023 or something." Well, with all the observations they've had of Apophis and other near-Earth objects, now Apophis is now downgraded because it appears it's going to probably escape and go somewhere else and probably hit somebody else.
There you go.
But that's the important thing.
Then they'll blame us and start a space war.
You mean the Venusians or the Martians will come out and wave their tentacles or antennas at us and shake their fists because we kicked Apophis their way?
No, the bugs that shoot asteroids from another planet at us.
Oh, you mean like in Starship Troopers?
There you go.
But as I say, the important thing about the space program is not just to explore the solar system or the universe. It's to actually have a viable deflection system in place. Yes, evil Spock the system lords were. But then again, the Asgards stepped in, and SG-1 was very good at tracking them. Evil Spock is putting a SG-1, a Stargate Team 1 comment into the chat room. I love SG-1. They actually did a story about an asteroid on collision with Earth, picked up by an amateur astronomer who thought he was about to be arrested and shut up. And all it was the case of was SG-1 just wanted all his information. They wanted all his photographs and orbital stuff so they could actually work on the orbit themselves. Just goes to prove, just because the military are asking you questions doesn't mean you have to be worried.
Mm-hmm.
But yeah, the important thing is, with all the amateur astronomers out in the world, if there was anything big, bad, and ugly coming our way, it isn't going to be silenced.
No.
Because of the simple fact is, even Roscoff, JAXA, NASA, ESA, and the Chinese couldn't silence all the world's astronomers. Their budgets could not pay to buy silence. And there's going to be somebody like me or Marty who would say, "What's this rock doing, and why is it coming at us?" And then we're gonna put pictures on Facebook.
I don't know about you, but I could be bought.
Depends what they're offering, Marty.
Yeah,
the way of bribes.
Not really. I could be bought. All right, $2.35 my starting point. All right.
I'm at least $2,500,000 start.
Yeah. Depends how close if it's going to be a hit or a miss. So if it's close, yeah, I'll take anything. If it's going to be a hit, it doesn't really matter if it's going to be a hit.
But this is the thing. Of course, the other famous non-story is Nibiru. It's supposed to be a rogue planet that hovers outside the solar system. It's going to be perturbed by a brown dwarf and sent in to smack into the Earth. I'm sorry. We have such good equipment now. We have stuff that is leaving the solar system. We have telescopes which to some degree can actually penetrate back to Planck time.
Mm-hmm.
We're actively looking for a large gas giant on the edge of the solar system.
Because if it's bigger than Pluto and it's at the distance of Pluto's orbit or a little bit beyond, it's easy for us to find. A lot of asteroid searches and new object searches are out there scanning the skies all the time. Usually they're discovering supernovas, novas, stuff like that, but there are lots of telescope systems that are looking for new lit up objects out there, and it'll be found.
It's not only that,
really
Marty.
fast. Yeah.
It's the fact that we are looking at how the trans-Neptunian objects are perturbed now.
Mm-hmm.
It's one of those things that's picked up in popularity, is to do the mathematical side of astronomy.
Yes. So there's obviously, well, some of the trans-Plutonian objects are out there that
No, trans-Neptunian.
Trans-Neptunian, yeah, Neptunian, Plutonian objects out there
Plutonium's
that
the radioactive isotope.
we could see their orbits, and we can watch their orbits, and we know if the orbits are being disturbed by another object, and that's our lead warning system for really big objects coming from pretty far outside.
And if you think about what New Horizons have been doing, a lot of their work has been to plot these objects, because when they were going beyond Pluto, they were looking for targets that would fit the fuel curve that was left, and they were actively involved in literally saying what's perturbing what and where. So if there isn't another big planet that's very dark and on the edge of the solar system, we're going to see perturbations in the Oort cloud, and certainly if it's really big, it may even affect the Kuiper belt.
And Ultima Thule is like twice as far out as Pluto, is it?
Yeah.
If I recall. So that's an object 10 by 20 miles across, twice as far as Pluto. So, and we're able to discover that and send our space probe in that direction. So yeah, there's lots of things, lots of telescopes out there looking for other objects, and that's pretty small for as far out as it goes. So anything that's sizable will be detected pretty far out. Imagine if that Ultima Thule was actually like 1,000 miles, 5,000 miles in diameter. Some people saying, well, yeah, there might be that what's that, Planet Narnia or whatever it's called. If that's going to be 8,000 miles across, we're going to see it really far out.
Yeah, and the thing is, the planet they've suggested exists mathematically. They reckon it's probably the size of Uranus. And that is going to cause major perturbations around it. It's not going to be simply small stuff that gets moved. It's going to be some of the bigger stuff too. And we're going to see its effects on the solar system.
Yep.
And of course, what gets me is all these conspiracy theories. Oh, it's coming in retrograde. It's coming in. It's not in the plane of the solar system. It's coming in from over the top of the solar system to smack the Earth. Now, the guy I used to know, I'm going to have to mention the name. I'll probably get smacked for this later. During my SCLU days, called Olaf Stevens, I think. And he's a professor of astronomy in Belgium. I think Glenn and you might remember him as well, Marty. He was actually a whiz at N-body simulations. And I think what he was saying to us in chat one time was a couple of his students got started on Nirabu, and it was a case of, well, I'll prove to you why they're saying it's going to hit in such and such a date is impossible. And he created an N-body simulation of the solar system with requiring a large planetary object coming in from over the top of the solar system and up from the bottom of the solar system, out of the plane of the solar system. And he says, when it actually, for the date they're claiming it's going to hit, it was a case of really, it's going to hit all right. It's going to miss us by at least twice the distance between the Earth and the Moon. And of course, that doesn't matter. It can move itself. Yeah, get a life, dude. No planet that big can shift itself sideways or speed itself up to catch up or hit the Earth just because the Earth is in the wrong position on that particular date. Now, I love watching N-body simulations because you can tweak the variables, but you have to remember there are multiple variables in effect here. It's not just the planet's course. You have Saturn, you have Jupiter, you have the Sun, and to a lesser degree, you have the Earth and Mars all playing against anything in the solar system. Yeah, it's space-time we're playing with here. And you've got to remember, space-time is curved. Where you have a planet, you have a curvature in space-time. It's kind of like the thing that I used to like in class was you'd have these tables with rubber sheets, and you would roll a big ball bearing, and you would see the rubber sheet deform under the ball bearing to represent the gravity well of a planet. This, by the way, is why the Enterprise cannot go to warp 1 in Earth orbit, and because it's in a gravity well. And to do that, according to Scotty and a few others, you would probably send your star nova.
Well, there's something we haven't seen coming. That's our station identification.
Yeah, well, we got too involved in a good conversation, Marty. Go for it.
All right. You're listening to the Event Horizon here on Astronomy.fm radio. It is another Friday evening. This one is March the 15th, 2019. About 9:30 in the evening for those of us here in the eastern portion of North America, and daylight savings time. Halfway through our program, so that means we still have another half hour of live astronomy radio for you. So stay tuned. Don't forget to come on over to our chat room and join us as we're reading it all the time too. So come on over and join us if you're just listening in. Come in to chat at our homepage, astronomy.fm.
In fact, Redshirt 3 has commented that he thinks the orbital period is estimated at 28,000 Earth years, and it's at perigee.
Apogee,
thank you.
Mm-hmm.
Anyway, the thing is, Nirubu's up whatever, and we would see it coming, and if the government tried to hush it up, I'm sorry, there's a whole bunch of amateur astronomers out there who would be gleefully screaming at the press, and the press would love it.
Mm-hmm.
Press would actually get to take down a government or governments for failing to not protect and serve.
Oh, let's see. Oh, quick one last notice here. Hey, we got Optronics in our chat room tonight. So one for you, Optronics.
I already welcomed into the chat room, Marty.
I know, but this is something different. This is, speaking of asteroid and stuff like that, a asteroid is actually going to cover up the star Regulus on March the 18th. Let me put that into our chat room. Okay. And it's only going to occur, unfortunately, in an area near the east coast of South America. Somewhat near, I don't quite know how far, but somewhat near Buenos Aires, north of Buenos Aires. So there's a link to it, especially for Optronics. Maybe he'll be close enough to actually see that happen. But if you're in the right area, happen to be right on the track, kind of north of Buenos Aires, and if you're watch it very carefully, Regulus, first magnitude star in Leo the Lion, will blink out for about 1.5 seconds because an asteroid is going right in front of it.
Now,
that's cool to see. Glenn
has made a comment in chat room.
Okay.
That it used to be thought that the asteroid belt may have been a planet. There was that change that was thought for a while. The problem is the mass is too low.
Mm-hmm.
So basically, the total mass of the asteroid belt is estimated to be by 2.8 times 10 to the power 21 and 3.2 times 10 to the power 21 kilograms. That's about 4% of the mass of the moon. Thanks, Black Projects. So yeah, as Redshirt points out, not enough mass to have been a planet. I know a lot of the sci-fi writers used to it was a ruined planet that got blown up by its inhabitants or something. Oh, the perils of nuclear weapons. But no, unfortunately, no. There's not enough mass in the asteroid belt to make a planet. Well, maybe a little moon, but that's about it.
Mm-hmm.
Okay, I found us another story, Marty.
All right, I got several stories. Go ahead.
Okay, so astronomers have investigating a recently reactivated radio magnetar. This is by Tomasz Nochalski on physics.org. A UK-German team of astronomers have conducted observations of a peculiar radio magnetar known as XTE J1810-197, which turned on December 2018 after a decade-long period of quiescence. Now, so what this is doing, this is providing even more observational information about magnetar properties. And they actually published a paper on xiv.org on March 6. Now, what they are, they're neutron stars with extremely strong magnetic fields, more like quadrillion times stronger than the magnetic field of our planet. So the decay of magnetic fields in magnetars powers the emission of high-energy electromagnetic radiation, i.e. X-rays or radio waves. To date, we've only identified about 23, And this one, which is XTE J1810-197, it has roughly a spin period of about 5.54 seconds and a magnetic field strength at a level of 2 trillion G. And it's only the first of Gauss, thank you. First of 4 known objects to emit radio pulsations. It was discovered originally in 2004, 1 year after an X-ray outburst from the source was observed. It's exhibited highly variable pulse radio emissions until about 2008, and then it went radio quiet. Now, anticipating the radio reactivation of this star, a group of astronomers led by Lena Levin of Jodrell Bank Centre for Astrophysics at the University of Manchester began observing this in 2009 with the Lovell telescope at Jodrell Bank. On December 8, 2018, they detected a bright pulse radio signal at 1.52 gigahertz from this source, which marked the end of nearly a decade of quiet. So it spent nearly 10 years in a radio quiet state, and then the X-ray pulsar turned back on, and they've actually also observed this at 1.5 gigs with a daily cadence since the first detection of reactivation on December 8th, the astronomers write in the paper. It's changed its profile. The pulse profile has changed since detection. However, the profile changes observed during the first 2 months were less extreme compared to when it was observed the last time when the source was active. The pulse variations so far seen have been less dramatic on timescales from hours to months than seen in 2006. So what they're saying is the spin frequency has increased by a factor of 2.6 over the 48-day data set, with the most rapid increase occurring in the first 15 days. So they've also discovered 50 millisecond oscillations in the pulse profile about 10 days after it was redetected. Those oscillations have a characteristic frequency of about 20 hertz. Yeah, LGMs, as Red Shirt 3 is saying in chat. Now, the authors are assuming that with such oscillations, it could be related to surface waves triggered in the neutron star crust with a wide spectrum of frequencies. So they're proposing further monitoring of this neutron star to find out whether or not the profile will experience more variations over time. And they actually do give a link. I'll just grab this link just 1 second for more information. If you really, and I'm probably going to download this paper and give it a good read. Yeah, Black Project, Grey's equal Asgard. Yeah, Thor and his chums. So there you go. There's a link to everything else. So I think it was a nice little story.
All right, cool. I got one here. Ring around the solar system.
Yeah.
Well, actually, there's quite a few rings around the solar system, but 2 of them I think have been recently discovered. A ring that's in the same orbital plane as Venus has been discovered, and I think I can't quite get through all the article whether one was suspected or discovered going around the sun in the orbit of Mercury. Mm-hmm. It turns out that some astronomers were looking for not so dusty regions around the inner part of the solar system, and they actually found some concentrated dust in the inner portions of the solar system. So when you get a lot of dust stuff there, it kind of gets in the way of your views, and they're hoping to find some nice clear patches, dust-free patches close around the sun. And no, they actually found some rings around the sun. The Venus one is associated with some asteroids that are in the orbital same orbit as the planet Venus.
And of course, ring planets are not actually rare occurrences anymore in the solar system. We know that further out in the solar system, I think it was Uranus was found to have them. Jupiter certainly has a ring. Yep. And of course, so it's becoming more and more a normal phenomena. It seems to be mainly gas giants that this happens to. Mm-hmm.
Depending on the type of rings, the densities, and all the other stuff like that too. So yeah. They're found some new ones in our own solar system. Kind of like, we've probably seen the images, or at least the artist conceptions drawings of early star systems with lots of ring systems going around them and disks around the stars. Now we have some for our own solar system too.
Yeah, Glenn says in the chat room, we live on a ring planet. Just look at all the junk up there. Yep.
That's true. Yep.
All that junk in the Clark belt. Yeah.
Yep. And we have less solar activity too, so that means the atmosphere is not extending out as far, so it's actually not catching satellites. So this sphere around the Earth is getting more and more junked up because a lot of the stuff that's up there should be coming down, like it would during solar maximum when it kind of inflates our atmosphere a bit, and that extended atmosphere catches on the satellites and helps bring them down and burning up in our atmosphere. Well, we get lots of that, lot less of that now. So we have a lot more junk.
This is very true. Yeah.
Mm-hmm. Also,
okay.
Magnetic fields are changing too because of the solar minimum. We're actually getting a lot more cosmic rays coming through, and they're starting to notice that. High altitude airplanes are getting zapped quite a bit by radiation from space.
Shall we have a look at this week's sky at a glance?
Sure, let's give it a glance.
Okay, so we're starting with today, of course, March the
15th.
15th, thank you.
Day after Pi
Look
Day.
for Arcturus, the spring star, very low in the east-northeast after nightfall, and higher in the east later in the evening. By modern measurements, Arcturus' visual magnitude of 0.05, making it the fourth brightest nighttime star. It's only beaten by Sirius, Canopus, and Alpha Centauri.
Sirius.
Sirius, potato. If you combine the light of Alpha Cent A and B, because the pair appear as single to the naked eye. So, on Saturday the 16th, very high after dark, Castor and Pollux point almost at the waxing gibbous moon near them. Ursa Major glitters softly high in the northeast these evenings, standing on its handle. You probably know the two stars forming the very front. The pointers, they point to Polaris, currently to their left. And if you know that if you follow the curve of, as it's described here, as the dipper's handle, and out and around by little more than a dipper length, you're arc to Arcturus rising in the east. Did you know that if you follow the pointers backwards, the opposite way, you'll land in Leo? Now, draw a line diagonally across the dipper's bowl from where the handle is attached, continue far on it, and you'll go into Gemini. Look at the two stars forming the open top, follow this line past the lip, far across the sky, and you crash into Capella. Sunday the 17th. This is the time of year Orion declines in the southwest after dark with his belt roughly horizontal. But when does Orion's belt appear exactly horizontal? Well, that depends where you're located east-west in your time zone and on your latitude. Okay, just reading what's going on in the chat room. And can you time the event? If you're near your time zone standard longitude, expect it around 9:15 this evening, daylight saving time more or less. Monday, the bright waxing gibbous moon transverses the sky in company with first magnitude Regulus. They're only a couple of degrees apart in the early evening for North America. Watch them pull apart further hour by hour. By Tuesday, the moon almost full shines in the dim left hind feet of Leo. Upper right after dark is Regulus, about a fist and a half at arm's length away. Left of the moon by about half that distance in Denebula, Leo's tail tip. Denebula is 0.8 magnitude dimmer than Regulus, meaning about half as bright. And it'll also be closer to the moon's dazzling glare. Depending on the clarity of your air, Denebula may or not be a challenge to pick out. Okay, Wednesday. Our full moon is exactly at 9:43 p.m. Eastern Daylight Time, and this qualifies as a syzygy. It's just 2 days after perigee.
Syzygy?
And synergy. Say we're using the right terms, Marty. We're not using astrological terms. It's just 2 days after perigee. The moon shines a trace brighter and bigger than usual. It's in the head of Virgo under Leo. Coincidentally, today, that Wednesday is also the equinox. Spring begins in the Northern Hemisphere at 5:58 p.m. EDT, when the center of the sun crosses the equator, heading north for the season. The sun rises and sets almost exactly east and west, and very nearly 12 hours apart. And no, eggs don't balance any better than they usually do. Okay, Thursday the 21st. Now that it's spring, the signature fall and winter constellations of Cassiopeia is retreating downwards after dark. But for sky watchers at mid-northern latitudes, Cassiopeia is circumpolar, never completely going away. Look for it fairly low in the north-northwest these evenings. It's roughly standing on end. Balance your eggs, says Glenn. Good luck. By midnight or 1 a.m., it's at its lowest due north, lying not quite horizontal. Algol, descending in the northwest, should be at minimum light for a couple of hours, centered on 10:04 p.m. EDT, 7:04 p.m. PDT. Algol takes 7 additional hours to re-brighten. And we will go back to this on the 22nd, when we'll be doing, hopefully, our next live show.
Mm-hmm. Good timing for equinox, too.
Yeah.
A little closer. I guess we'll save it for next week to talk about the equinox then.
Yeah.
But that means basically the same world. The whole world has pretty much the same night length and day length at the equinox.
Now, one thing I want to mention quickly, I know this has been asked of me. I think I can't remember if it was Quiet in the Woods or somebody else. Can you save the chat? So tonight I am trying to save the actual chat room as well.
Can you save the chat? Is that what you said?
Yeah. Basically, what I'm doing, I've cut and pasted the chat room.
I see. Okay, and you're going to put it where you're going to put it in your YouTube
put it in
stuff.
The show notes.
Okay, sounds good.
Actually, again, I was thinking more the electric eel. Glenn has commented, Nick will slap me with a kipper if I'm not careful. I was thinking again with the electric eel, give you a nice, nice little surprise.
Okay.
No, it's not necessarily. I'm only kidding, Glenn. You know that. So it is 1:52 a.m.
p.m. 1:52
a.m.
Gotcha. Universal time.
Thank
yes,
you.
Gotcha. when does the UK go on summertime, by the way?
31st.
31st? Okay. Let's see, what do we got? Some more articles on... Oh, I know what I had one on. Scientists have discovered 83 new quasars.
Cool.
Powered by supermassive black holes. Let me put that article into our chat room here. Here we go. Copied and pasted. Yes. Now, the idea on this is that these are actually smaller than the big ones. The big ones obviously were found first because when stuff goes into a black hole, it releases a whole bunch of energy. And if it's a lot of stuff in a really big black hole, then they appear to be really, really bright. And the first ones that were discovered were also discovered to be really far away. In fact, so far away that we're like to the edge of the universe. And yeah, that's true. They were called quasars, quasi-stellar objects, because they appeared to be point-like, really small, but they're emitting a tremendous amount of light, being determined by how far away they were, which is determined by the redshift of them. So they're wondering.
Asked a question.
Well, what's the question?
Are they beacons? Do you think?
Are they what?
Are they beacons? That's what he said.
Are they
beacons? Do you think?
They're not beacons. No. Now that would be something. A beacon would be more likely something in our own solar system. Not our own solar system, in our own galaxy. So these are way, way far out. So it's about 13 billion light years away, something like that. And the biggest and brightest ones, quasars, were discovered first. There was a big mystery about that. In fact, originally they thought they were maybe something that was ejected from other galaxies because they always seemed to be found near galaxies. Well, it turned out that was a coincidence, that because the images that were taken of galaxies were able to pick up these quasars, and then it was later found, the quasars are pretty much evenly scattered around our entire nighttime sky. They're really far away, really bright. And they thought, well, in the early parts of the universe, is there a lot of black holes? Not a lot of black holes. Well, we've seen these quasars, which indicates black holes, but they haven't found a lot of quasars. Well, it turns out that we were only seeing the brightest ones. Now, these 83 quasars are much smaller and dimmer than the ones we've been seeing before. So that's why they're hard to detect. So now it's thought that there is a lot of black holes that were formed in the very early parts of the universe, just less than 1 billion years after the formation of the universe, after the Big Bang. So now that'll help them figure out that, yes, there was a lot more black holes formed early, and still trying to figure out why that was. Got a lot of ideas about that, like a lot of stars, supermassive stars, went right from being stars, blowing up into and shrinking right into black holes and collecting together. That's pretty cool.
Yeah. I think the thing is, as our technology progresses, we are getting to a point where we're actually discovering more and more things.
Mm-hmm.
Glenn says, we did mention time travel a bit ago. I think that's the whole thing about astronomy. It is time travel, but it is one-way time travel.
Right.
So we're only seeing the past.
Now, you might catch an article sometime about a two-way, something going back in time a little bit. It was kind of a computer thing with a single atom.
With a particle and antiparticle.
It wasn't an antiparticle. I can't remember quite what it was, but I don't know. It was kind of like, well, maybe not. Maybe it was a cold fusion type of thing. Well, we'll see if they actually got a particle to travel backward in time for a fraction of a second. We'll see how the other people do that and see if they get the same type of results. It's a little more of a kind of like an antiparticle type of thing. It's like, well, we think it's there, but is it there? Is it really happening? Is it not really happening? We'll see. Take that one and just file it away for the future and see if it gets, if it's reproducible and if it continues on.
As Stephen Hawking said about his birthday party, he didn't send out invitations. So if there was a time traveler in the future, he can't exist because he never came to the party.
That's right. There's a Big Bang Theory thing on that too.
Yeah.
See that episode?
I kind of enjoy watching that. I also liked him turning up in Next Generation, playing cards with Data and Einstein. Mm-hmm. But saying of Orion, it's back off schedule again. SLS, yeah, you got it. It's off schedule again. In fact, the head of NASA stood up and said that he was really pleased with SpaceX, but SLX is behind schedule again. That's okay. Right. The invite wasn't delivered because he's in the past, and the time traveler doesn't exist in the future.
Okay. Well, we got about a minute to go. Yeah, 2 minutes or so, minute and a half. What do we want to end this with? What do we want to do? Well, let's see. We got a occultation of Saturn by the moon coming up. Next one will be March 29th, and that'll be basically centered on South Africa. And there's actually one almost
for a holiday.
Yeah, almost every month, and they're getting farther and farther south as time progresses until the very last ones near the end of the year will be in Antarctica visible. Mm-hmm. So,
which means unless it's very good weather, we ain't going to get to see it.
That's right. It's December, which is summertime there, so
there is.
Well, you have to see it in the daylight, though.
Mm-hmm.
Oh, well, it's getting to be about that time, I think, Nick, for us to head out. Maybe time to call the ship.
Yep. Okay. Captain Savick, this is the away team. A whole bunch of us to beam back this time.
Yeah.
Myself, Marty, Starstrom, Glenn, Evil Spot, Red Shirt 3, Optronics, and Black Projects. Energize.
All right. Thanks, everybody. Appreciate you listening in. Thanks, everybody in the chat room tonight. More programming coming up, so stick around. Good night, all.
Thanks for visiting.
We hope that you've enjoyed this program from AFM Radio, the broadcast service of Astronomy.fm. This program has been released under Creative Commons license. Please contact us for details. You may find more of our AFM original programs on our website. It's really easy to find us. We are Astronomy.fm. You may also find us in the iTunes radio listings near the top of the News Talk section, and also as an iTunes podcast selection. We'd love to hear your comments. Please email us at radio@astronomy.fm. Thanks so much for being part of the voice of astronomy around the world and across the known universe. This is Astronomy.fm Radio.
Hi, this is Tavi Greiner, Astronomy.fm's Vice President of Communications. If you enjoy our programming, please let us know with a donation to astronomy.fm/donate. We really do rely on your support, and it's true, every little bit counts.
AFM.
There I was, doing my thing, and all of a sudden, wham! Astronomy right between the eyes.